Now this illustration deals with a metal underground water pipe, basically when it's an electrode, in accordance with 250.52A1. Now kind of coming out the gate here, we've said before, you have to evaluate that water pipe. And if 10 feet or more of it is in the earth, it is considered an electrode in accordance with 250.52A1. But if you had non-metallic utility coming in, then it's not an electrode, and you'd go to 250.104C as in car. And what's the difference? Well, you could bond to it anywhere accessible. You wouldn't have to bond to it within 5 foot where it enters the building if it's not considered an electrode for 250.52A1. But now in this illustration, it is considered an electrode. We have 10 feet or more of it in the earth. It's a metal water pipe. 250.104A or 250.52A1 is used here. But under any condition, Table 250.66 will size the grounding electrode conductor based upon the utility supply conductors or a customer-owned supply from the transformer with no overcurrent device ahead of the conductors. Now, keeping this in mind, 250.104A now is when it's not an electrode. You have PVC outside instead of 10 feet or more metal water pipe, so to speak. Now, notice if it is an electrode, then you have to bond within 5 feet where it enters into the building. And you're going to terminate and use a fitting in accordance with 250.68C1. But the 5 foot comes from 250.52A1. But now you're going to have to supplement that water pipe. Now either you have to do that with a foundation steel and you say, no, this is new installation, can't get to it. Well, the code says you don't have to tear up the foundation. You can bypass it if it's existing. So you would use a driven rod, as you see in the illustration, to supplement the water. It would be a number 6 is all you would need to that driven rod in accordance with 250.66A. But when you install it by 250.53, 8 foot or more of it has to be in the earth and it has to be protected from physical damage, see? And then we tell you if you want to look at this with another figure loop, see figure 16-73, which we will be coming up on shortly. But notice here, the driven rod is used as a supplementary electrode to the water pipe. So we're using 250.53, D as in dog 2, and we're using, say, 250.54, 250.53E, 250.53A2 exception. Now, when we look at these rules and we see that that rod has to have a 25 ohm or less resistant reading, and we have to comply with the sections that we see up there. 250.54 used to be 250.56, as I mentioned in the previous illustration, and it's an auxiliary type rod driven to equipment outside in most cases to provide equal potential grounding, to divert surges away from certain equipment and so forth. So notice the grounded conductor still is sized from table 250.102C1 to serve as an effective ground fault path, and then sized as a neutral from 220.61 and the larger used. But based upon the 250 kc mill terminating into the service panel board, then notice we need at least a number 2 over to the water pipe from table 250.66 based upon the 250 kc mill requiring a number 2 to connect the grounding bar in that panel board to the water pipe, and then a number 6 over to the driven rod by 250.66. Now that's what our illustration 16-65 is illustrating how to ground the metal water pipe with the appropriate size grounding electrode conductor and supplement it, in this case with a rod. You'd say, well, what if the concrete encased electrode was bonded in? Then you supplement it. You don't have to supplement it one time. But in this case, we're not using the concrete encased electrode. It's existing in this case, and it can be exempt from you having to go in and use a jackhammer and damaging the footing and the foundation and so forth. So that's what this illustration 16-65 is illustrating.